Hello, my name is Nathan Baker, and this is my grandfather paradox presentation. So, first, a few key concepts for the grandfather paradox. Um, first we're going to ask ourselves what it is in the first place. So, basically, the grandfather paradox says that if you were to travel to the past, um, if you killed your grandfather, you couldn't have done that because if you killed your grandfather, you couldn't have existed, and therefore you couldn't have gone back in time to kill your grandfather, right? So, if you're confused about what I just said, you can think about it in this, right? So, go in the past, kill your grandfather, your dad's not born, you're not born, you don't create the time machine, you can't go back to the past, your grandfather's alive, therefore your father's born, you're born, you create a time machine, you go to the past, you kill your grandfather, and then it just doesn't make sense, right? That's just the whole thing. And so, from what we can gather from this, okay, first things first, Um, the situation isn't exclusive to killing one's grandfather, but greater in any action that can affect the past. So, if you were to kill your mom or kill, uh, like your grandmother, same thing. And like also if you were to like get someone to like kill you, that would also work. Anything that affects the past, um, would trigger this sort of result. So, unsurprisingly, this kind of problem raises many questions and theories. My personal favorite, though, is the many worlds interpretation. This basically says that, like, for each new decision, there's like new universes that are created to that like one specific decision. So if you were to like decide to like get a red cup, like to drink water out of instead of a blue cup, that would be in the universe. Just like literally any decision, right? So I think that'd be the coolest. Um, because then there would be like a universe where like you, your dad, your siblings are all gone, but there's still like a functioning universe, right? It's not just like you're stuck in a loop. That's my personal favorite interpretation. Now, of course, this is yeah, like I said, this is just an interpretation because we don't exactly know what would happen, although there are a few ideas. This is a video that gets its own
As far as we
conclusion.
know, time only moves in one direction, forward. But if you could loop back to visit the universe at an earlier point in time, a famous paradox arises. What if you killed your grandfather when he was a child? Then your father or mother wouldn't have been born, so you wouldn't have been born, so you wouldn't have been able to go back in time to kill your grandfather in the first place. Paradox. The simplest resolution to the grandfather paradox is that when you go back in time, you're actually not going back into your own history, but to a copy, and everything you do there influences the new alternate future of that universe, not your own past. But that's boring because it just avoids the paradox. If what you do when you go back in time actually influences your own past, and the effects of your time travel do loop back to the present, future, past, no problem. Let's just follow the paradoxical timeline through beyond its paradoxical conclusion. You go back in time, kill your grandfather, thus you aren't born, so you can't go back in time, thus your grandfather isn't killed, thus you are born, so you go back in time and kill your grandfather, and so on. I'm showing this as a looping linear series of events, but really it's two entangled histories happening in parallel. Is that even possible? Well, I don't know about the time travel part, but subatomic particles regularly do multiple different things in parallel. It's called quantum superposition and is responsible for the weirdness of the double slit experiment, many properties of atoms and molecules, fusion in the sun's core, and so on. So if the universe were to exist in a superposition of two states, your grandfather's alive and your grandfather is dead, then the natural result is a superposition of two states. You're born and able to go back in time to kill your grandfather, and you're not born. And the natural result of these is a superposition of two states. Your grandfather is dead, and your grandfather is alive. And so, at least from a logical perspective, this looping timeline is entirely consistent and there's no paradox. And a similar paradox-free solution can be obtained by viewing the problem as a steady-state solution to a Markov chain, but I won't go into that here. Now, of course, nothing about these solutions to the grandfather paradox suggests that closed time loops are actually possible. In fact, some of the implications this kind of time loop have in the study of complexity theory seem to suggest that time loops, and thus time travel into the past, must be impossible. But the main point is sometimes we think a situation creates a paradox paradox when it doesn't. And really, the only paradox is how our thinking can be twisted enough to dream up time-traveling murderous grandsons, but not twisted enough to think about twisting time.
Video, right? And here are my citations. And thank you for watching.